Good afternoon, sir.
So today we are going to discuss some examples based on L'Hopital rule. So what is L'Hopital rule? Sarvottam.
Sir.
Abhay, what is L'Hopital rule?
रूल तो पता नहीं है पर उसमें क्या
You
करते हैं
remember the statement? When you can apply L'Hopital rule?
આપણે લિમિટમાં જ્યારે 0/0 નું ફોર્મ આવે ત્યારે.
Yes. Either it is 0/0 form or infinity upon infinity
by
form.
infinite.
And L'Hopital rule can be used for finding limit of function. Okay. So let me take some examples. So the first example is this. Limit x tends to 0 plus sin x upon under root x. We want to evaluate this limit. Okay. So if you take x equal to 0 in this limit, then sin 0 is 0 and root 0 is 0. So this is 0/0 form. Okay. So directly you can apply L'Hopital rule. So this is nothing but limit x tends to 0. Limit of this is how much? It is exactly equal to derivative of sin x with respect to x, derivative of root x 1 upon 2 root x. So this is nothing but limit x tends to 0 plus now 2 root x into cos x. Now put x equal to 0, your limit is 0. So 0 is the answer. Okay. Now let us consider another example. Limit x tends to 0 1 minus cos x upon x square. Now we want to evaluate this limit. Okay. So if you take x equal to 0, cos 0 is 1, so 1 minus 1 is 0. So numerator is 0. Now if you take x equal to 0 in the denominator, okay, denominator is x square. So if you take x equal to 0, so this becomes 0. So this is 0/0 form. So L'Hopital rule can be applied to find out this limit. So this is nothing but limit x tends to 0. What is derivative of 1? 0. This is plus sin x. Derivative of cos x is minus x. Now this is nothing but limit x tends to 0 sin x upon 2x. So 2 is constant, so it can be taken outside of the limit. And this is exactly equal to sin x upon x. Now what is limit theta tends to 0 sin theta upon theta? This is always 1. So your answer is 1/2 into 1, that is 1. Therefore limit x tends to 0 1 minus cos x upon x square is equal to 1. Okay. So this is the answer. Now let me take another example. Next one is this: e raised to x minus 1 upon x. Now if you take x equal to 0, e raised to 0 is 1. So 1 minus 1 is 0. This is 0/0 form. So L'Hopital rule can be applied to find out the limit of this function. So limit x tends to 0. Now what is derivative of e raised to x? E raised to x. Derivative of 1 is 0. Derivative of x is 1. So by putting x equal to 0, you will get answer as 1. Now let's take another example. Limit x tends to 0. E raised to x minus 1 minus x upon x square. Now if you take x equal to 0, numerator is 0, denominator is also 0. So this is 0 by 0 form. So this limit is limit x tends to 0. What is derivative of e raised to x? E raised to x 1 0, and this is minus 1 upon 2x. Now again, if you take x equal to 0, this is 0 by 0 form. Okay, e raised to 0 is 1, 1 minus 1 is 0. So now 1 upon 2 is constant, so I can take it outside of this limit. And derivative of e raised to x is e raised to x, and derivative of x is 1. Derivative of 1 is 0. So now if you take x equal to 0, your answer is 1. So whole answer is 1 by 2. Therefore limit x tends to 0, e raised to x minus 1 minus x upon x square is equal to 1 by 2. Okay. Now let us consider another example. Do you understand?
Yes, sir.
Okay. Now limit x tends to infinity ln x. Ln x means log x base e upon x. So if x tends to infinity, ln x tends to infinity. So this is infinity upon infinity form. Okay. So according to L'Hopital rule, limit of this is derivative of ln x is 1 by x, and this is 1. So this is nothing but limit x tends to infinity 1 by x. So what is limit of x tends to infinity 1 by x? This is 0. So therefore you can say that limit x tends to infinity ln x upon x, limit is 0. So next example is this. Very simple examples. Okay. Limit x tends to infinity e raised to minus x into x square. Now this is not 0 by, this is not in 0 by 0 form or infinity upon infinity form. Okay. So what we can do, see, this can be written in this way. Limit x tends to infinity. I will keep x square in the numerator and I will bring this into denominator. So it becomes e raised to x. Now put x equal to infinity. So x square is infinity. So this is infinity upon infinity. So now you can apply L'Hopital rule or Hopital rule. Limit x tends to infinity. Derivative of x square is 2x and derivative of e raised to x is e raised to x. Now 2 is constant, so it can be taken outside of the limit. Limit x tends to infinity. This is nothing but x upon e raised to x. Now this is 2 limit. What is derivative of x is 1 upon e raised to x. E raised to x. Now x goes to infinity. 1 upon infinity is 0. So the answer is just 2 into 0. So 0. Therefore limit x tends to infinity, x square upon e raised to x 0. Now from this you can say that exponential function is more increasing in compared to x square. Okay, see, if you take x tends to infinity, then x square goes to infinity and e raised to x goes to infinity. Both tends to infinity, but e raised to x is much faster than x square. Okay, ये कैसा है, अगर आप नवसारी जा रहे हैं, बस में जा रहे हैं और मर्सिडीज कार है उसमें जा रहे हैं, तो किस में जल्दी पहुंचेंगे? हम मान लेते हैं कि मर्सिडीज कार है, उसकी स्पीड बहुत ज्यादा है। सर्वोत्तम,
यस सर।
हाँ, किस में जल्दी पहुंचेंगे आप?
सर कार में ही पहुंचेंगे।
हैं?
कार में जल्दी पहुंचेंगे।
हाँ, so next example is this. ln sin x upon ln x. Fine. So x tends to 0 plus. Okay, see, sin 0 is 0. Why I have taken limit from right side? The reason is this: you cannot define log function for negative numbers. Okay, so we are approaching 0 from right side. Okay, so due to this reason I have taken limit x tends to 0 plus, otherwise there will be a problem in the definition. See, in the neighborhood of 0, if x is positive, sin x is positive. Sin is positive from 0 to pi by 2. So we can say that in the neighborhood of 0, sin function is positive. So this makes sense. I mean, ln sin x makes sense. Okay, so this is infinity upon infinity form. ln 0 is infinity. Okay, so now we can apply L'Hopital rule. So this is nothing but limit x tends to 0 plus, what is derivative of this? 1 upon sin x into cos x upon 1 by x. Okay, so this is exactly equal to limit x tends to 0 plus, x goes to numerator, x upon sin x into cos x. Do you understand? Now apply algebra of limit. Limit x tends to 0 plus x upon sin x into limit x tends to 0 plus cos x. So what is the limit of this as x tends to 0? This is 1 and this is 1. So answer is 1. Okay, next example. X minus sin x limit x tends to infinity, x minus sin x upon x plus sin x. Now if you take x equal to infinity, see, sin lies between minus 1 to 1, but here x minus sin x. So as x tends to infinity, x minus sin x tends to infinity. So this is infinity, and similarly denominator goes to infinity. So this is infinity upon infinity form. Therefore you can apply L'Hopital rule. So this is nothing but limit x tends to infinity, derivative of 1 is, the derivative of x is 1. This is cos x, 1 plus cos x 1 minus cos x upon 1 plus cos x, and x tends to infinity. Now this limit exists. This does not exist. Why? Can anybody give the reason? See, cos oscillates between -1 to 1. What is the range of cos function? Closed interval -1 to 1. So if your x tends to infinity, sometimes cos takes one value, sometimes cos take -1 value. Okay, so this term does not remain constant as x goes to infinity. Due to this reason, this limit does not exist. Okay, so here I cannot apply L'Hopital rule. The reason is this: L'Hopital rule can be applied only when f dash x upon g dash x and limit x tends to infinity. This should exist. Okay, limit x tends to infinity. This was the condition in L'Hopital rule: f dash x upon g dash x. This cannot be dropped. This should exist. See, look at this. This doesn't exist. What does this mean? I cannot apply L'Hopital rule to solve this example. Since limit x tends to infinity, f dash x upon g dash x does not exist. Okay, so due to this reason, so now how can we find out this limit? Anybody? Abhay, do you have any idea? See, take x common from numerator. See, so this is x, this is 1 minus sin x upon x. Similar way, take x common from denominator. So you are left with this 1 plus sin x upon x. So now x gets cancelled. Okay. So you are left with this. Now apply algebra of limit. So this is nothing but limit of 1 is 1. And what is the limit of 1 minus sin x upon, as x tends to infinity? This goes to 0, sin x upon x. And this goes to 0. So our whole answer is 1. Now here we have used this fact: limit x tends to infinity, sin x upon x, this is 0. Why? Okay. Why this limit is 0?
सर हम
Yes.
1 तो कांस्टेंट हो गया, उसको लिमिट तो 1 ही होगी. उसके बाद माइनस
There are two
लिमिट
results.
x टेंस
Limit theta. See, if your x tends to 0, then what is limit of sin x upon x?
1
Yes,
1.
1. But if you take x tends to infinity, this limit is 0.
Okay.
See, why this 0? The reason is this: 0 less than or equal to mod sin x upon x. What is the range of sin? -1 to 1. So mod sin x is less than. Do you understand? Now limit x tends to infinity. So what is the limit of 1 upon x as x goes to infinity?
0.
0, and apply sandwich theorem. So modulus of this has limit 0. Therefore, limit x tends to infinity sin x upon x is equal to 0. So ये confusion होने वाला है. देखिए, if you take x tends to infinity, then sin x upon x goes to 0, and if you take x tends to 0, this goes to 1. Do you understand? So don't
Yes,
put
sir.
here 0 or 1. If you put sin x upon x equal to 1, you will get wrong answer. Okay. So the reason is this. Fine. Therefore, the limit is. So this is a very nice example, though it is small. See, we cannot solve this example by L'Hopital rule. Clear? So in the statement of L'Hopital rule, you cannot drop this condition. Limit x tends to infinity, f dash x upon g dash x. This must exist. Then only you can apply L'Hopital rule. Okay. So now let us consider another example. Next one is this. Limit, let I equal to, let they have given me I 0 to pi by 2, and consider this limit. X tends to 0 plus 1 upon x minus 1 by sin x. See, this is not in the form 0 by 0 or infinity upon infinity. So somehow we need to bring this into infinity upon infinity or 0 by 0 form. Okay, so what we can do here, see, take LCM as x into sin x. So this is nothing but sin x minus x. Okay, now if you take x equal to 0, then numerator is 0 as well as denominator is 0. Therefore, we can apply L'Hopital rule, provided f dash upon g dash exists. Now, what is derivative of sin x? This is cos x. Derivative of x is 1. This is x cos x plus sin x. Okay. So again, if you take x equal to 0, if you take x equal to 0, cos 0 is 1. So 1 minus 1 is 0. And in the denominator, if you take x equal to 0, this denominator also 0. So this is again 0 by 0 form. So again apply L'Hopital rule. So limit x tends to 0 plus, what is derivative of cos x? This is minus sin x. Derivative of 1 is 0 upon minus x into sin x plus cos x. What is derivative of sin x? Cos x. So this is equal to, see, now if you take x equal to 0, numerator is 0, but now look at this. Here x into sin x, this term is 0, but cos 0 is 1. So 1 plus 1 is 2. So the answer is 0 by 2. So 0. So what is the limit? Limit x tends to 0 plus 1 upon x minus 1 by sin x. Limit is 0. Okay. Now let us consider next example. Next one is this. I equal to 0 to infinity limit x tends to 0 plus x into ln x. Okay. Now this is not in the 0 upon 0 or infinity upon infinity. So this is not in indeterminate form. So we need to bring it x tends to 0 plus x into ln x. Now this can be written in this way: limit x tends to 0 plus ln x upon 1 by x. Now if you take x tends to 0 plus, this term is infinity and this is infinity. So this infinity upon infinity form. Okay. So limit x tends to 0 plus, what is derivative of ln x? This is 1 by x, and derivative of 1 by x is minus 1 upon x square. So this is nothing but limit x tends to 0 plus minus x square upon x. Do you understand? So what is the answer? 0. So limit x tends to 0 plus x into ln x, this is 0. Okay. So let us consider next example. Next one is this. Limit I equal to 0 to infinity. So we are taking domain 0 to infinity. Okay. This is of the form fx raised to gx, x raised to x. We want to find out this limit. So this is of the form fx raised to gx. So in such type of example, see, limit x tends to 0 plus x raised to x, this can be written in this way: limit x tends to 0 plus e raised to ln x raised to x. Okay. Limit x tends to e raised to x ln x. Okay. So do you understand? See, e raised to ln x is equal to x. Reason is this. Clear? Abhay,
sir.
do you understand?
Yes, sir.
Okay. So okay. So now let us bring this into ln x See, now this is now. So this is nothing but. So what is derivative of 1 ln x?
One upon x.
1 upon x, and this is minus 1 by x square. Okay. So this is 1 upon x. So this is 0. And e raised to 0 is 1. Therefore, limit x tends to 0 plus x raised to x equal to clear, Mr. Abhay?
Yes, sir.
देखिए, whenever your function is of the form fx raised to gx, you need to convert into this e raised to ln x raised to x or e raised to ln fx raised to gx. Okay, from this you can bring it into 0 by 0 or infinity upon infinity form. Okay.
Okay, sir.
So now, all right. Sorry. Let me share the screen. I think screen is not visible. Okay.
Sir.
See, the next example is this. I equal to 0 to infinity. Limit x tends to infinity 1 plus 1 by x raised to x. Okay. So let me find out this limit. See, this is again fx raised to gx. Okay, so note that 1 plus 1 upon x raised to x, this can be written in this way, e raised to ln 1 plus 1 by x raised to x base e. Okay, so this is nothing but e raised to x ln 1 plus 1 by x. So therefore this limit, now in order to find out limit this, it is sufficient to find out limit of this. So since e is continuous function, we need to just find out limit x tends to infinity x ln 1 plus 1 by x. So this is x ln, so this is equal to see, you can write in this way 1 plus 1 by x upon 1 by the way, anyway. Okay, now see, if x tends to infinity, 1 upon infinity tends to 0, x tends to infinity, 1 upon x tends to 0. So this is log 1, that is 0 by 0 form. Okay, now you can apply L'Hopital rule. Okay, what is derivative of ln? This is 1 upon log, derivative of ln is 1 upon 1. So now what is derivative of this? Okay, so now this gets cancelled. Minus 1 by x squared. Do you understand? See, derivative of ln x is 1 upon x. So this is 1 upon 1 plus 1 by x. Now derivative of 1 is 0. Derivative of 1 by x is minus 1 upon x square. So this gets cancelled. Yes? Do you understand? Okay.
Yes, sir.
So x tends to infinity. This tends to 0. So this is 1. Okay, so limit x tends to infinity, x ln 1 plus 1 upon x is 1. So the limit of this, let me say this to be 1. Therefore, by 1, we get limit x tends to infinity x plus 1 by x raised to x is equal to e raised to, this answer is 1. So the answer limit is e raised to 1. Clear?
Yes, sir.
So next example is this. Limit x tends to 0, x square x tends to 0, x square see, if you take x equal to 0, this is 0 by 0 form. Okay, so what is derivative of this? 2x minus 2 sine x 4x cube. Do you understand?
Yes, sir.
So this is equal to, so now you can take 2 common, or you may, I will keep this outside of this limit 1 by 4. I will, x tends to 0. So this is 2x minus sine. I think we have seen this example before. X square minus sine square x upon x raised to 4 or x raised to 3. What was the example? So no, let us see. So this is 1 by 4, this is x cube. Okay, 1 by 4, limit x tends to 0. What is, again this is 0 by 0 form. 2 minus 2 cos 2x upon 3x square. Okay, This is 1 by 12, limit x tends to 0, 1 minus cos 2x upon x square. Okay, so now again if you take x equal to 0, cos 0 is 1, 1 minus 1 is 0, so this is 0 by 0 form. Limit x tends to 0, 2 sine 2x upon 2x. Okay, so this is 1 upon 6, limit x tends to 0, sine 2x by 2x. Now theta tends to 0, sine theta upon theta is 1, so this is nothing but 1 by 6. Clear, Abhay?
Yes, sir.
So limit x tends to 0, x square minus sine square x upon x raised to 4 is equal to 1 by 6. So next one is this. X raised to sine x. Limit x tends to 0 plus x raised to sine x. So this is of the form fx raised to gx, and x belongs to 0 to infinity. So interval is also given. So this is fx raised to gx. Okay. So not that. I can write in this way: x raised to sine x e raised to ln x raised to sine x base e raised to sine x ln x base e. Okay, so suppose I want to find out this limit, it is sufficient to evaluate this limit as x tends to 0 plus. So now let me evaluate this limit. Limit x tends to 0, sine x into ln x is equal to limit x tends to 0 plus ln x upon sine means 1 upon cosec x. Clear? Now if you take x tends to 0 plus, this goes to infinity. And cosec x बराबर 1 upon sine 0 means infinity. So and this is equal to, this is infinity upon infinity form. What is derivative of? What is derivative of cosec x? Minus cosec into cot x. Okay. Now see, look at this. Cosec can be written in this way: limit x tends to 0 plus, this is sine x upon x, cot is tan x. Clear? 1 upon cot is 10. So now apply algebra of limit. 10x. Clear? So now this is 1 and this is 0. So 0. So limit x tends to 0 plus sine x into ln x is 0. So what is limit of this? X tends to 0 plus x raised to sine x this is nothing but e raised to 0 okay. Okay, so x tends to, next example is this, try for this one. Anyway, let us consider this. Sec x minus 10x. Now, okay, this is x raised to sine x. Now let me take sine x raised to x. Next example is this. See, this is x raised to sine x. Now let me take x tends to 0 plus sine x raised to x. Okay. So note that sine x raised to x, this is nothing but e raised to ln sine x raised to, okay, so now you can see this is nothing but this by the property of log. This can be written in this way, x ln, okay. So let me say this to be 1. So now let us find out this limit. X ln sine x, okay. So now this can be written in this way, limit x tends to ln sine x upon 1 by x. So see, if x tends to 0 plus sine x is 0, so log 0, this is infinity upon infinity form. So limit x tends to 0 plus, what is the derivative of ln? This is 1 by sine x into cos x upon, this is minus 1 by x square. Okay, so this is equal to x square upon sine x into cos x. Okay, so now x upon sine x, as x tends to 0, that is 1, so this limit is nothing but limit x tends to 0 plus x into cos x. The reason is this, okay. So now take x equal to 0, cos 0 is 1 and this is 0, so this limit is 0. Okay, so by 1 x tends to 0 plus sine x raised to x is equal to e raised to 0, that is 1. Okay, clear? Do you understand?
Yes, sir.
Okay, so next example is this. Sec x minus tan x. Okay. See, if you take x equal to pi by 2, sec pi by 2, it is infinity. Infinity minus infinity form. So this is not in 0 by 0 or infinity upon infinity form. So we need to bring it into 0 by 0 form or infinity upon infinity form. See, this is equal to limit x tends to pi by 2 minus what is sec x? Sec x is nothing but 1 by cos x minus sin x upon cos x equal to limit, so 1 minus okay. Now if you take pi by 2 in place of x, so sin pi by 2 is 1, 1 minus 1 is 0, and cos pi by 2 is also 0. So this is now 0 by 0 form. So this limit is nothing but limit x tends to, so this is minus cos x and this is minus sin x, so minus minus plus. Now take x equal to pi by 2, so this limit is cos pi by 2 is 0, sin pi by 2 is 1, so this limit is 0. So therefore limit x tends to pi by 2 minus sec x minus clear.
Yes, sir.
Okay, clear.
Yes, sir.
So we stop our discussion. Okay, so this is about L'Hopital rule. So next time we will see some new examples. Okay. So goodbye everyone.
Goodbye, sir.